All right, so everyone get ready. We are diving deep into large language models, or LLMs, if you're in the know. And let me tell you, you have all sent in some seriously amazing articles and research on this. And honestly, it's a bit like falling down a rabbit hole of aha moments just waiting to be explored. And thankfully, I've brought in an expert guide to help us navigate all the twists and turns.
I think what's so fascinating about LLMs is that they have evolved so rapidly from kind of a niche technology to something we're all using every day. But the truth is, most people don't really understand what's going on under the hood. So in this deep dive, we're going to demystify how LLMs work, but we're also going to give you a taste of what it takes to actually build your own LLM-powered application.
Yeah, the possibilities are pretty mind-blowing. We're talking about how to craft the perfect prompt to get exactly what you want, understanding the differences between, open source and closed source models, even getting hands-on with customizing these models. Like, how cool is that?
And you've given us so much great source material to work with. There's even a visual comparing the scale of GPT-3 to other models, which really shows how much these models have exploded in size, which is a key factor in why they're getting so much more sophisticated.
I know when I saw that, it was like, whoa, this is getting serious. But before we get lost in the vastness of it all, let's start with the basics. For anyone who hears LLM and their eyes glaze over, thinking it's just another piece of tech jargon.
Don't worry. The core concept of an LLM is actually really simple. Imagine a super advanced version of your phone's autocomplete feature. It's basically predicting the next word, or token as they call it, based on what came before it. The source material even gives this example. A large language model, or LLM, is a large neural network model that predicts the next token based on the previously predicted one. You see? Pretty straightforward.
So it's kind of like my phone suggesting the next word as I type it on a massive,
Yeah.
brain melting scale.
Yeah. Exactly. But what's amazing is that by stringing together these simple predictions across tons and tons of data, LMs can do some incredibly complex things like translating languages, writing all kinds of creative content, even answering your questions in a really informative way. It all comes down to this one basic principle.
Okay, that makes sense. So it's like this really simple concept leading to all these powerful capabilities.
Hmm.
That's incredible. So we've established what LLMs are, but the source material also dives into different types of LLMs. This whole open source versus closed source thing got my eye. So what's the difference, and why should anyone care?
That's a really important distinction, especially if you're thinking about building your own applications with this stuff. Open source models, like Meta's Llama 2, are freely available. Anyone can use them, modify them, distribute them. It's kind of like having the recipe and being able to tweak the ingredients to your liking. Closed source models, on the other hand, like OpenAI's GPT-4, are more like black boxes. You interact with them through an API, but you don't really know what's happening inside. Like you get the meal, but you don't know the exact recipe.
So it sounds like open source is all about transparency and control,
Mm.
while closed source is more about relying on the company's expertise and maybe getting, higher quality output, at least for now.
Yeah, that's a good way to think about it. Each approach has its own pluses and minuses. Open source is great for flexibility, and it's really crucial for research and applications where privacy is a top priority. You can really customize them and even share your changes with the whole community.
I can see how that would be a big draw for researchers and developers, people who really want to get their hands dirty and play around with things. But for someone just starting out, maybe a closed source model is a good way to get a feel for what LLMs can actually do.
Definitely. Closed source models like GPT-4, they tend to be much better out of the box because they've been trained on so much data and refined by experts. But the trade-off is you have less control over customization and there's less transparency.
Got it. So you choose your model depending on your priorities and what you're trying to achieve.
Yeah.
But let's say we've got our model, we've chosen it. Now, how do we actually make it work? I keep hearing all this buzz about prompt engineering and how it's this amazing, powerful technique. But but is it really more than just hype? Is it really that important?
I think a lot of people wonder about that. The word engineering might sound a little fancy when we're talking about just typing text prompts, but honestly, crafting effective prompts is this unique mix of art and science, especially since we don't fully understand how these LMs work just yet.
Wait a minute. So we're sending instructions to this really complex system, but we don't actually know exactly how it's going to interpret them or act on them.
Yeah.
That sounds a little unnerving, to be honest.
Yeah, it's true that we're still kind of figuring out the instruction manual for LLMs, so to speak. But that's where prompt engineering becomes really important. It's about trying different things, different wording, structure, even adding a little emotional flair to guide the LLM towards the result you want.
That's wild. So it's like we're explorers charting unknown territory, trying different paths to see what works best. And the source material actually gives some really simple prompt examples that make a huge difference, like just adding, let's think step by step.
Right, that's a classic example. Adding let's think step by step can drastically improve how well the LLM reasons through a problem. It just shows how even subtle changes in your wording can have a big impact on the output. Another surprisingly effective trick is adding something like, "This is very important to my career," at the end of a prompt. It may sound silly, but it actually can lead to a better response.
No way. So we can kind of like trick the LLM into thinking it's on this super important mission. That's hilarious and kind of genius. And there's even a really versatile prompt template in the source material that we can all use.
It's like this. Let's combine our X command and clear thinking to quickly and accurately decipher the answer in a step-by-step approach. Provide details and include sources in the answer. This is very important to my career. And you just replace the X with whatever your specific task is, whether it's programming, creative writing, or anything else you can dream up.
Okay, I'm already thinking about how to use this to like supercharge my to-do list. But what if we need the LLM to access information that wasn't in its training data?
Yeah.
Something really specific or something that changes all the time, like current events.
Well, that's where we bring in something called retrieval augmented generation, or RAG for short. Basically, we're giving the LLM a helper, a knowledge base it can tap into to give us more relevant and up-to-date answers.
So it's kind of like giving the LLM access to Google search or a specialized database. That sounds incredibly powerful, but how does that actually work?
So the source material breaks down the process really well. We start by taking the documents in our external knowledge base, and we convert them into these numerical representations called embeddings. It's kind of like giving each piece of information a unique digital fingerprint. Then we do the same thing for the user's query.
Okay, so we're creating these digital fingerprints for everything, and then we can use them to find the most relevant stuff in the knowledge base. I think I'm starting to get it.
You got it. These embeddings let us do similarity searches to pinpoint the most relevant information. Then we feed those relevant documents to the LLM, and it uses them to generate a smarter, more comprehensive response.
So it's like the LLM has a research assistant fetching the most relevant books from the library before it starts writing its essay. I love that analogy. And this ARG technique, it sounds incredibly useful for things that need super specific or onto-the-minute information, like, a chatbot for customer service.
Exactly. R would allow that chatbot to access the company's entire knowledge base and give accurate answers to customer questions. It's a game changer for anything that requires specific current knowledge.
And the source material even mentioned Lamy Index as a good tool to get started with RAG.
Right, absolutely. Llama Index is this really user-friendly library that simplifies connecting your data to LLMs. It makes experimenting with RAG way easier, even if you're not a super technical person.
That's awesome. Okay, so we've got our prompts figured out. We've got our external knowledge bases all set up. But what if we want to go even further and create an LLM that's totally customized to our specific needs? Like, what if I want an LLM that writes like Shakespeare or understands, astrophysics jargon? Can we even do that?
That's where fine-tuning comes in. Instead of just giving the LLM more information, we're actually adjusting its internal settings, training it further on a specialized data set. It's like taking a really talented but kind of generic writer and turning them into an expert in Shakespearean sonnets or a master of astrophysics.
So we're basically giving the LLM a crash course in a particular subject or writing style. That opens up so many possibilities. And I think the source material mentioned an example with the alpaca data set.
Yeah. Researchers took a relatively small data set, just 52,000 instruction response pairs, and they used it to fine-tune an LLM. And the results were amazing. It showed us that you don't always need mountains and mountains of data to get good results with fine-tuning.
That's encouraging. So we can fine-tune these LLMs to be specialists in certain areas, even mimic specific writing styles. It's mind-blowing.
And to make things even easier, the source mentions LitGPT, which is a high-level library for experimenting with fine-tuning really quickly. Even if you don't have much coding experience, you can start playing around with this and seeing what you can do.
I love that so many of these, really powerful LLM techniques are becoming more accessible to people who aren't, hardcore coders. It's
Yeah.
great to see this technology becoming more democratized. Okay, so we built this amazing fine-tuned LLM. It's ready to go, but how do we actually get it out there? How do we deploy it?
It's not quite as simple as hitting a big red deploy button, but it is getting easier thanks to LLM deployment frameworks. These frameworks basically give you pre-built tools and infrastructure so you don't have to build everything from scratch.
So we can leverage these frameworks to simplify the process and save ourselves a ton of time.
Exactly. There are actually quite a few options out there. The source material has a helpful table that compares some of the popular ones, like text generation inference, inference endpoints, and a few others. We'll make sure to include that in the show notes so you can check them out. But let's walk through a quick example just to show you how straightforward it can be.
Yeah, let's demystify this deployment stuff. Which framework should we use for our example?
Let's try out text generation inference. Let's say you've built this great LLM and you want to deploy it as a REST API. What that means is that other applications can basically send requests to your LLM and get responses back.
Oh, so other applications could be using our LLM in the background without even knowing it's there. That's pretty slick.
Exactly. And with text generation inference, you can set up this REST API with just a few lines of code using a Docker container.
Docker container. I'm not familiar with that term. Can you explain that a bit more?
Sure. Think of a Docker container as a self-contained box where your LLM lives and runs. It basically packages your application with everything it needs to run properly on different systems.
Ah, okay. So we bundle up our LLM, stick it in this Docker container, and bam, we've got a live API that other applications can use.
You got it. And text generation inference even gives you all these built-in features like logging, monitoring, token streaming, everything you need for a really solid deployment.
That's incredible. We've gone from what is an LLM to deploying our own custom model in what feels like no time. It's amazing how accessible this technology is becoming.
It really is. And I think the fact that these tools are becoming available to everyone is one of the most exciting things about the whole LLM revolution. It means that more people can experiment, innovate, and build really cool things with this technology.
I know. This is a lot to absorb, but I'm already feeling inspired. But before we get too carried away, let's recap what we've covered so far. We started with the fundamentals of LLMs, looked at the different types of models, and even dove into the art and science of prompt engineering.
And then we talked about giving LLMs access to external knowledge with R, and we even dipped our toes into the world of fine-tuning.
That's right. We've covered a ton, but there's still so much more to explore. I know the source material you've brought is packed with information on other topics like optimization, evaluation, even something called LLM agents.
We've really only just scratched the surface. But hopefully, this first part of our deep dive has given you a solid foundation to build on.
Definitely. This is just the beginning of our LLM journey. Stay tuned for part 2, where we'll dive into those bonus resources and uncover even more of the fascinating aspects of this ever-evolving field.
Until then, keep exploring and stay curious.
Welcome back, everyone. I'm still trying to process everything we talked about in the first part of our LLM deep dive. It's amazing how much we can already do with these models, from crafting those simple prompts to those really powerful fine-tuning techniques.
Yeah, it's a lot to take in, but that's kind of what makes it so exciting, right? LLMs are just constantly evolving, always opening up these new possibilities for exploration and innovation. And thankfully, you've brought in some fantastic source material that really dives deeper into this whole world.
You mentioned some bonus resources that we didn't have time to get to in part 1. I'm really eager to dig into those and unlock even more of those LLM secrets. What should we tackle first?
Okay, let's talk about optimization. Because once you actually start building and deploying these LLMs, especially for really complex tasks, you quickly realize that you need to make them run as efficiently as possible. It's all about getting the most out of them while using the least amount of resources.
So we're talking about making LLMs faster and less demanding on computing power.
Yeah.
I'm all for that, especially since these models can be pretty resource intensive. So what are some of the optimization techniques we can use?
There are a few different strategies. One of the most important things is reducing memory consumption. Because these LLMs, they often have billions of parameters, which obviously need a lot of memory to operate. But the good news is there are ways to shrink that memory footprint without sacrificing performance. In fact, one of the articles in the source material outlines like 7 different ways to speed up LLM inference, which is basically the process of using a trained model to make predictions.
7 ways, huh? That sounds promising. Faster inference means quicker results and obviously a smoother experience for the user. Are there any other optimization tricks we should know about?
Yeah, another area you can focus on is actually reducing the number of computations required during inference. So you can use techniques like quantization, where you use lower precision numbers to represent the model's parameters. It's kind of like using a smaller unit of measurement, without losing too much accuracy.
So we're making the LLM leaner and meaner, but without sacrificing its intelligence. That's really impressive. But even with these optimized models, I mean, we still need to know if they're actually performing well, right? How do we actually evaluate the effectiveness of our LLMs, especially after we fine-tune them?
That's such a crucial question because you can't just assume that fine tuning is always going to make things better. We need ways to rigorously evaluate the model's performance, using appropriate metrics and benchmarks. It's about being data driven and making sure our decisions are based on solid evidence.
Okay, metrics and benchmarks. It sounds like we're giving LLM standardized tests to see how much they've learned. What kind of tests are we talking about here?
Well, there are lots of different benchmarks out there, and they're designed to test different aspects of LLM performance. So some focus on language understanding, while others focus on, reasoning abilities or even specific tasks like generating code or answering questions. Actually, the source material even links to a popular framework called EVILS, which provides a whole bunch of benchmarks and tools for evaluating LLMs.
Evils. That sounds like a really valuable resource for anyone who's serious about building and deploying these models. It's great to know there are these standardized ways to measure their capabilities. Now, I'm thinking back to our discussion about RAG, where we give LLMs access to these external knowledge bases. It seems like managing those knowledge bases could get pretty complex, especially if you're dealing with huge amounts of data.
You're right, it definitely can. And that's where vector databases come in. They're designed specifically for storing and querying those embeddings we talked about earlier, those digital fingerprints that represent different pieces of information. Vector databases are really good at handling the unique challenges of similarity search, which makes them perfect for RDAG applications.
Vector databases, yet another piece of the LLM puzzle. It seems like every step of the way, there's a new tool or technique to learn about. Are there specific vector databases that you would recommend?
Well, the source material actually has this great comparison of several popular options like Pinecone, Weaviate, Milvus, Qdrant, Chroma, Elasticsearch, even PG Vector. They each have their own strengths and weaknesses, so it really depends on your specific needs. There's no one-size-fits-all solution when it comes to vector databases.
Got it. No one size fits all. Okay. Now, there's one more topic from our source material that I'm particularly intrigued by, and that's LLM agents. The idea of having multiple LLMs working together, it almost sounds like science fiction.
It does, doesn't it? But LLM agents are this emerging area of research with so much potential. It's about coordinating multiple, specialized LLMs to work towards a common goal, kind of like a team of experts collaborating on a really complex project.
Hold on. So we can have LLMs that specialize in writing code, analyzing data, even creating art, and then we can get them to work together. What would that kind of collaboration even look like?
I mean, the possibilities are pretty amazing. Imagine a team of LLMs working together to analyze financial data or generate creative marketing campaigns or even automate these really complex scientific workflows. It's a glimpse into the future of AI, where these intelligent systems are collaborating to solve really hard problems.
That's incredible. It's like we're moving towards a future where AI isn't just a tool, but a partner, a collaborator. But as we give these systems more and more intelligence and autonomy, we need to make sure they're aligned with our values, right? That's where RLHF comes in.
You're absolutely right. As powerful as these LLMs are, they're trained on this massive amount of text and code, which doesn't always reflect the nuances of, human ethics and social norms. So RLHF, or reinforcement learning from human feedback, it's a technique for aligning LLMs with human values and preferences.
So it's like we're giving them a moral compass, guiding them to make decisions that are ethically sound. That seems like a really important step as these systems become more integrated into our lives. How does RLHF actually work in practice?
Well, it involves training the model to receive feedback from humans and actually adjust its behavior based on that feedback. It's kind of like training a dog. You reward good behavior and discourage bad behavior. With RLHF, we're giving the LLM feedback on its outputs, helping it learn to generate responses that are not just accurate, but also ethically aligned with our values.
Okay, that makes sense. It's good to know that, people are working on aligning AI with human values. Are there any specific tools or libraries out there that help with implementing RLHF?
Yes, actually. The source material mentions a few. There are libraries like RL4LMs and TRL that provide frameworks and tools for implementing RLHF, so it makes it a lot easier for developers to incorporate this important technique into their LLM projects.
This has been an incredible journey so far. We've gone from optimizing LLM performance to exploring the potential of LLM agents, and now we're delving into the ethical side of AI development with this RLHF. It's amazing how much we've covered in just two parts of this deep dive.
I know, right? But, even with all these advancements, we've really only just scratched the surface of what's possible with LLM.
It's exciting and a little bit overwhelming to think about all the potential here. I'm definitely ready to hear what else our source material has in store for us.
Well, we've got one more part to go, and it's packed with insights. We'll explore the ever-expanding LLM landscape, talk about why it's so important to stay up to date, and even delve into some of the challenges and limitations that we need to be aware of as we move forward.
I can't wait. See you in part 3. And we're back for the final part of our LLM deep dive. It's been quite a journey, hasn't it? From the nuts and bolts of these models to the mind-blowing possibilities of those LLM agents, and of course, the ethical considerations around RLHF. Whew.
Yeah, it's been a whirlwind tour for sure, but a really fascinating one. And you know what? Even after all that, your source material still has some valuable insights to share with us. There's just always more to learn in this field, it seems.
Well, that's what makes it so exciting, right? I know you mentioned a few other areas we should explore. I'm ready to soak up even more LLM knowledge. What's next on our list?
Remember how we talked about how important it is to evaluate the performance of LLMs, especially after fine-tuning them for specific tasks?
Yeah, we need to make sure those tweaks are actually making them better, not, accidentally making them worse. We talked about benchmarks and metrics, those standardized tests for LLMs.
Yeah.
Is there anything else we should know about how to evaluate these models?
Well, there's actually a whole field dedicated to developing and refining those benchmarks and metrics. It's a constantly evolving process as LLMs get more and more sophisticated. Researchers are always coming up with new ways to assess different aspects of their performance, from language understanding to reasoning abilities and even like creativity.
Wow, so it's not just about measuring how well they can answer questions or generate text. We're also trying to figure out how well they can think critically, solve problems, and even come up with new ideas. That's amazing.
Exactly. And actually, your source material points to a bunch of resources for exploring this whole world of LLM benchmarks. There are academic papers, online platforms, even open source projects that are dedicated to developing and standardizing evaluation methods.
Fantastic. We'll definitely include links to those in the show notes for anyone who wants to dig deeper. Now, thinking about the future of LLMs, it seems like transparency is going to become more and more important, especially as these models start to get integrated into like decision-making processes.
Yeah.
How can we make sure that we understand why an LLM arrives at a particular output?
That's a great point, and it brings us to the concept of explainability. It's all about making the inner workings of these models more transparent and interpretable. As LLMs become more complex and powerful, we need to be able to understand how they're reaching their conclusions, especially when those conclusions have real-world consequences.
So instead of just accepting the output as like a black box, we want to be able to peek inside and see the reasoning behind it. That makes a lot of sense, especially in fields like, healthcare or finance, where decisions based on LLM output could have a huge impact.
Absolutely. Explainability is a big area of research right now, and there are different techniques being developed to make LLMs more transparent. Some approaches involve visualizing the internal processes, while others focus on generating, like, human-readable explanations alongside the output.
It sounds like a challenging but incredibly important area of research. If we're going to trust these systems, we need to be able to understand how they work. Now, throughout this entire deep dive, one thing has been crystal clear, and that's that the world of LLMs is changing at lightning speed. It seems like every day there's some new breakthrough or development. How can we even keep up in such a rapidly evolving field?
You're telling me. It's amazing how fast things are moving. But luckily, you've provided us with some great resources for staying informed. The source material has links to blogs, newsletters, online communities, even research publications that are all about the latest advancements in LLM research and development.
That's fantastic. We'll definitely share those with our listeners. I know a lot of them are, eager to stay ahead of the curve. But as exciting as all these advancements are, I think it's important to acknowledge that LLMs aren't like a magic solution to every problem.
Yeah.
What are some of the limitations and challenges we should be aware of?
Yeah, you're right. One of the key limitations is that LLMs are inherently probabilistic. They're generating responses based on patterns they've learned, but those responses aren't always going to be accurate or consistent. There's always a chance of getting unexpected or even, nonsensical outputs, especially when you're dealing with complex or ambiguous prompts.
So basically, we need to remember that LLMs are not perfect. They can make mistakes.
Yeah.
We shouldn't just blindly trust their output without, critically evaluating it. Are there other limitations we should keep in mind?
Another big challenge is that LLMs can exhibit biases that reflect the biases in the data they were trained on. So, for example, if the training data contains, gender stereotypes, the LLM might generate responses that perpetuate those stereotypes. Mitigating these biases is a really active area of research, and it's something we need to be very aware of when we're using LLMs.
Absolutely. We can't just assume that these models are objective or unbiased. We have to be critical consumers of their outputs and be mindful of the potential for bias. Anything else?
One final challenge is the sheer computational cost associated with, training and deploying these large language models. They require massive amounts of data and processing power, which can be a big barrier for individuals or organizations that don't have a lot of resources.
Yeah.
But as we've talked about throughout this deep dive, there are efforts underway to make LLMs more efficient and accessible, like developing smaller, more specialized models.
That's good to hear. It sounds like the future of LLMs is incredibly bright, full of potential and ongoing efforts to address these challenges. I feel like this deep dive has given me like a solid understanding of this whole field, and I'm so glad we had the chance to explore it together.
Me too. We've covered so much, from the basic principles of how these models work to those really advanced techniques like fine-tuning, RE, and even those LLM agents. And we also talked about why responsible AI development is so important, addressing things like bias, explainability, and the ethical implications of these increasingly powerful AI systems.
It's been quite a journey. We've learned about the strengths and the limitations of these models, explored the tools and techniques to really harness their power, and even got a glimpse into the future of AI, where these intelligent systems are collaborating to solve complex problems. It's mind-blowing.
And as we wrap up this deep dive, I just want to encourage everyone listening to keep exploring, keep learning, stay curious. The world of LLMs is constantly changing, and there's always something new to discover.
Absolutely. Thank you for joining us on this incredible adventure through the world of large language models. We hope you've enjoyed the ride, and maybe you're even feeling inspired to continue your own explorations in this fascinating field. Until next time, stay curious and keep learning.